just discuss our topics, and then if time permits, we will go for notes. These are very easy. So we are talking about the PN junction diode, and we have two small topics and two medium topics. We cannot extend more than today on this chapter. PN junction diode. And a PN junction diode is a piece of a semiconductor which has a P type on one side and an N type on one side. Obviously, you will have metallic contacts on both sides, right? These are my metallic contacts. And are you now comfortable, all of you all, as majority charge carriers? The majority charge carriers on this side will be holes. Agreed? Obviously, we will have some hole accumulation on the N end, and similarly, we will have minority charge carriers as electrons on this side, and we will have some electron accumulation on this end. I hope this much is fine and understood. Okay, and this region is called the depletion region, and a potential will be created out here which is known as the barrier potential. So the barrier potential will not allow further diffusion. Then we learned about something called diffusion current. Diffusion current is when the semiconductor is left alone. First there will be diffusion of charge carriers, majority charge carriers crisscross, and a diffusion current will set up. And once the diffusion current has set up, it will then give rise to an electric field which will be set up out here. The electric field will give rise to a barrier potential and will not allow further infiltration of the majority these charges onto each side. Means no more electrons will drift towards this side, no more holes will be drifting, not drifting, diffusing towards this side. Is this much understood? Right. Now, when we talk about a PN junction diode, the PN junction diode is represented in this manner. This is the symbol for a diode, right? And this is your P, this is your N. Now, there are two ways of connecting this diode. The first one is known as the forward biased method. Forward biased. Forward biased means connect the diode in such a manner that the proper terminal is connected to the, means exact terminal to the exact battery. What I mean to say out here in forward bias is this will be the diode, right? And I will connect it in such a manner. This is what end, beta? PN. So the PN will be connected to the positive side of the battery, of the cell or the battery, and this will be connected to the negative end. Have you understood? So if you want to see that diagram out here, Arjun, you're able to see? Okay, so this is the diagram. This is called a forward bias. So this is positive, this is negative. Let's see what happens in a forward bias. So when you apply a forward bias this diode and you apply a voltage which is more than the barrier potential, Now look, this is positive. The positive is connected with this side. So all the positives will be repelled from this end, and all the negatives will be repelled from this end. In a way, you are actually making the positive and negative get accumulated at the junction. But at the junction, you have an electric field which says, no, you know it's going to come here. That's the barrier potential. So if your applied voltage, if the applied voltage is greater than the barrier potential, okay, is greater than the barrier potential, then what you do, you allow combinations to happen, electron hole pair combinations to happen in this junction. As a result, a current will start to flow. This is very easy to understand. Hope you have understood. I'll make you write the points also. So there will be combination of electron hole pair at this junction, and the current will start to flow. What you need to remember is that this current is due to the majority charge carriers, right? So one electron that is pumped out of the negative terminal, pumped out. A battery does not produce electron. A battery is like a pump, electromotive force. One electron pumped out, just see this, one electron pumped out goes to the negative. Finally, it will do a combination, and one valence electron will be leaving what? This particular side and getting inside to the battery. And a current starts flowing, and we say that my diode has started to conduct in forward bias. But there was a condition. The diode initially will not conduct. It will conduct only when your applied voltage is more than the barrier potential. So in your labs, when you do an experiment, we do an experiment which is known as the forward bias characteristics. Okay, so characteristic means curve. So it's a VI diagram. It's a VI diagram, and in order to see, if you do it in a lab, you will be actually connecting a voltmeter out here to see what is the potential out here. Okay, And then we can do what? We can put one variable resistance out here. This is in your lab. If you variable resistance means you can increase the voltage or reduce the voltage, right? And you can connect one emitter out here in series. Now just see. Initially make the resistance very high. So this is behaving as simply as an insulator, right? It's behaving as an insulator. Try to understand. If you have any issue, let me know. Slowly I start reducing the resistance. So I'm making current to flow, or I'm applying more voltage. As soon as you reduce this resistance, this voltage will start picking up, picking up, picking up. However, this will not show any deflection. That means I have yet not crossed the barrier potential. Once I cross the barrier potential, you will see a sharp rise in this emitter. Means the diode has started to conduct freely. So it will be something like this. Initially, we will have a very small non-linear phase. This is the phase where you are trying to increase the voltage, but you have still not applied enough voltage worth for the diode to conduct. Once you reach that voltage, which is the mark out here, I call it V0, and this is known as knee voltage. Okay, knee voltage. And these readings are what you have to plot. This reading, this reading, this reading, this reading, this reading, this reading, and then a freehand curve has to be drawn. Once you reach the knee voltage, you will see there is a linear section. Means it has become a conductor now. So this region will be actually following Ohm's law. And for this region, there will always be some I dash current for some applied voltage, which is V dash. So you will get some dynamic resistance out here, which will be, dynamic resistance is very small. So it's any change in delta V by delta I. We call it as a dynamic resistance. Knee voltage is the barrier. See, barrier potential is the voltage given to it's the same thing. It's the same thing. It's how do I tell you? Price of the product, what I am paying, aren't both same thing? Price of this pen is 10 rupees. So you want it? Give me 10 rupees. So the 10 rupees will be termed in two ways. Price of the product. Barrier potential from the diode's perspective. You want it? Pay me. Expenditure. But the value is same. Knee voltage is from what you are applying. So once you cross knee voltage, immediate combination happens, and this has become a conductor. Happy conductor. And it will conduct, but afterwards when you apply more voltage than this, and then there will be a breakdown. Why this breakdown happens? Ohm's law. Current flowing through a conductor is directly proportional to the voltage. You are going on increasing the voltage, so the current increases. Current increases, I square RT, the heat increases, so the diode will burn out. But nobody will operate at this zone. This much is sufficient. So I had something like, go by the RO example that I gave. So I had an NRV valve where the plate was fallen. I've opened the tap, slowly, 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 slowly I've increased, and this plate has started to lift. Now my valve is as good as a conduit, a pipe. Free water is flowing through it. That's forward bias. And in labs, this will be a milliammeter. This will be a milliammeter when we do it in labs. Have you understood the basic of forward bias? Okay. So in forward bias, remember, P terminal is connected to positive, N terminal is connected to negative. Key points, although I'll narrate to you. P terminal with positive, N terminal with negative. Current is due to majority charge carriers. Therefore, you will get very good current because majority charge carriers are carrying the current. Current is due to major. Current flows once your applied voltage is beyond the knee voltage. But you don't know knee voltage. You don't know knee voltage at first. You will go by an experiment and you will see at a particular voltage, I start getting a linear characteristic. That minimum voltage, also known as the threshold voltage, we also call it as the threshold voltage, at which a diode starts connecting, is known as, actually we get very less time, otherwise we can show you on breadboard experiments also. You can put a LED, put the diode, put 3 volt across it, the LED will glow. Okay, see how to do this thing right here. If you want to say we have a small LED out here, okay, and in this LED we will connect a diode in this manner. Got it, children? And then we will connect this to a cell, a 3 volt cell. The LED will be happily glowing. But what we will do, we will deliberately put some resistances out here. We'll put a resistance, trial and error resistance. We'll put some high resistance. High resistance means you are not supplying enough voltage to the diode. So diode is sitting silent, LED won't glow. Go on reducing this resistance. At a particular resistance, this diode will start glowing bright. That means for that resistance, the voltage that you get is actually the knee voltage. You have just overcome the barrier potential. Are we fine? Have you understood this concept? Any doubt on forward bias? So I'll just see if I missed out anything on forward bias. Okay, so let's see and enjoy it. Just listen to what I say. So forward bias, terminal connections, you know. Now recombination will stop. Now if a battery can overcome the potential barrier, current flow can resume. So initially there will be some current flow, then electric field will come up, then no more current flow. In forward bias mode, majority charge carriers in both sections are drawn towards the junction. Nothing new. Majority charge carriers from both sections are drawn towards the junction. Negative repels electron in N and positive repels pushes the holes towards the junction. Right? Free electrons and holes combine at the junction. For each combination, one electron is pushed to the negative terminal or the N side, and one valence electron leaves the P side and enters into the battery. That's all. Right? Remember one thing, you get a very good current when you forward bias the diode. Shall we see reverse bias now? Okay, let's see the reverse bias condition. So we'll draw our PN junction once again. So this is my P, this is my N, and once again, I have holes out here, right? And some hole buildup will take place out here. And I have electrons and some electron buildup is taken here. Let me complete the metallic ends of my diode. So these are my metallic ends. Okay, this is my PN junction right now. So let's go by the story. I have my semiconductor. Initially, when it is not connected, what will happen? There will be a diffuse current which will be set up, and the diffuse current will go build up to a portion. What will happen? The electric field will come up. The electric field will stop any further diffusion, creating a barrier which is called and develop potential here called the barrier potential. At this stage, however, some minority charge carriers will definitely crisscross to each other, and that will constitute what is known as drift current. And under equilibrium, drift is equal to diffusion current, so no current flows through this diode. Now what we will do, we will be connecting this diode in such a manner that the P type is connected to the negative terminal and the N type is connected to the positive terminal. Now we will do reverse. So this is known as my reverse biased. The diode is said to be reverse biased. Ulta connect karenge, reverse. Now look, what will happen? Once you connect the N type to the positive terminal, all the electrons start getting pulled towards this side. Don't you agree? And all the holes get pulled towards the negative side. Let me rephrase my word. I would say the positive charge carriers, not say the positive, the majority charge carriers of each section are further pulled away from the junction. Junction is the place which is like the Bharat Milan happens, right? This is the wedding hall. So you're pulling the bride more this side, you're pulling the groom more this side. The majority charge carriers of either section, like the electrons for N type and the holes for P type, they're being pulled on both sides, and which causes furthermore spread of the depletion zone. Conductivity is lost for all good. You can't expect the diode to conduct now, because conduction depends upon combination of electron hole pair. But one interesting thing will happen. What is the interesting thing? That there are some minority charge carriers on either side. Don't you think? There are some minority charge carriers on either side. This particular orientation or this polarity that we have set up will help this minority charge carriers. Just look, positive is going to push this positive more towards the junction, and the negative is going to repel the negatives, the little negatives towards the junction, and some recombination will happen. Therefore, a very small current will flow, which will say a very small current will flow, small current. And this current will be in microampere range. Remember, in experiments, the teacher will always ask this question: what type of emitter did you use in reverse bias? Microammeter, not milliammeter. Small current will flow, and this small current is due to what? Minority charge carriers. And the story is same. For every electron hole pair that has combined here, which electron hole pair, children? Minority electron hole pair. One negative charge will be pushed from the negative terminal, and one positive will leave the N side now and will come out here. The same thing. So if we plot a characteristic curve of this, now since this is reverse bias, so we will draw this graph on our third quadrant, right? This is a negative voltage which you are giving. Here the V is negative, and this is the current, and the current will be now always in microampere. Fine. So how will the characteristics be? There will be a constant, very small current that will flow. Absolutely straight, very small, and absolutely straight, very small. It keeps flowing. A straight curve because the current is constant. Once you apply that voltage, this is that small current which is flowing. It's a negative current. However, if we increase the reverse voltage after a certain level, the diode breaks down and shows excellent conductivity. This is not good for you. This is, you have damaged the product. Did you understand this? This is like, now you made the plate move this side. Now you are pushing water from the other side. The plate will never move because the plate is supposed to move only in one side. Now you're pushing water from this side. So the plate is trying to hold. You are so ruthless. You increased it so much that the plate has now just moved up, and it has moved up forever. Now if you think, children, that, sir, I stopped the entire circuit current and I again started to flow the current in the circuit. Look, that time you will not get this graph. That time you will just get a straight graph because you have already damaged. Ye toot chuka hai aapka. Therefore, we say in semiconductors, unless and until you do something wrong, the semiconductor will never damage your product. And though you'll learn about some applications of this, that book covers it in a very short way. We will cover it a little bit detailed so that you can understand it nicely. So I always say this is the best way to understand. This is my cell phone and this is my battery bank. Yes or no? Your phone charges at 5.1 volt. So what do? You will actually put one diode out here, and then you will connect it. And so this is the positive of your phone charging cable. This is the negative. So every time the battery bank is charging, the current goes this way. One fine day, the battery bank no more has charge in it, but you have a full charged cell phone. You can't expect that the cell phone will charge the battery bank, because at that time this diode becomes reverse bias. This diode will become reverse bias. So it will not allow you to. This is how we do it. Okay? So let's see if any point we have missed out, because those notes also cover them very nicely. I'll just read some of the things. Reverse bias means P region has a negative terminal, N region has a positive terminal. We have covered it. Electron from N side will be attracted towards positive, and positive terminal negative will attract all the positive holes from the positive terminal. This also we have done. Reverse bias will repel majority charge carriers away from the junction, and majority current cannot flow. This also we have discussed. Reverse bias can, however, cause minority current to flow in reverse direction. This is what we saw. Minority charge carriers are pushed towards the junction, they recombine and allow an electron to enter. So it's the same thing that keeps on happening. You should know some things like non-linear zone in a forward bias, linear zone, breakdown, knee voltage, and here also you should know the breakdown voltage. Like you had a knee voltage, this voltage, this is the voltage at which the child has damaged it. So this will be known as by breakdown voltage. What happens at breakdown voltage? At breakdown voltage, the diode starts conducting because the PN junction has been destroyed. Okay? And the diode starts conducting. We call it as an avalanche breakdown, though not in your syllabus. Now let's see what are the applications of this diode. Now, if I cover it like book, you will just mug it up and you'll not understand anything. What is the beauty part of it? Okay. So one of the use of diode is to be used as what we call as a rectifier. Okay. रटोगे तो कुछ नहीं समझ में आएगा. Let's understand what is a rectifier, right? Let's understand what is a rectifier. So all the devices that you use, the electronic devices, like you're using a mobile charger or you're powering your Apple mini pod or your Alexa or something, you all have these adapters. Have you seen set-top box and adapters? Or your modems for that purpose. Okay. Majority of our devices work either on 6 volt DC or on 9 volt DC or on 12 volt DC. Everything will be working on electronics is all in DC. Alternating current won't be there. So how do you get these DC? Buy some cells and put them inside your apparatus. The cells will die down one day, then the performance will go down. So we do not rely on them, right? Look at the camera that we are using. The camera is also being powered right now from the AC source. But the camera is an electronic device, it's not using AC. Inside it, everything is DC, even your laptop. So what do? You connect everything to your wall outlet, and being in India, your supply voltage is 240 volts AC with a frequency of say 50 hertz. And if you were in US, it would have been 110 volts AC with say 60 hertz as the frequency. You are actually doing two things. The two things are happening. First, you are converting AC to DC. Also, you are stepping down the voltage. We are stepping down the voltage. 220 volts or 240 volts, whatever it is, okay, 240 volts are being stepped down to 6 volt. How is this magic happening? Understood? This is what we have to study. Now, let's see this part. This part earlier that was there in your grade 10. Now, that is what I say, when you make syllabus shorter, you make it difficult in grade 12. So we have, but if you are from Cambridge, you will have learned it. You have a device called a transformer. I won't go that much how it works because you will be anyway studying the transformer as a part of your AC circuit. So what is a transformer? A transformer typically has, have you seen a frame of a photo frame? So I'm trying to draw a photo frame. Iron plate, just a simple iron plate. Like if I put it on the ground, it will make its noise. Very thin. Many such iron plates join together so that it forms a laminated core. This is a laminated core. In this, what we will do, we will have two types of windings. One winding, and on this side we will have another winding. Right? Wire. Insulated copper wire, just like in grade 10 what you studied. Copper wire. This side will be known as my primary, this side will be known as my secondary. This is my primary coil and this will be known as my secondary coil. There will be some number of turns, so I say NP is the turn and NS is the secondary turns, number of turns that we will give. Now see, when you supply an alternating current to this one, when you supply an alternating current to this one, an alternating current will always create, you know, current carrying conductor behaves like a magnet, but this is alternating. Kabhi seedha, kabhi ulta, kabhi seedha, kabhi ulta. It will create, it will change the magnetic field which will be linked with this particular coil. Once this magnetic field changes, then we see what is known as Faraday's law of induction. We'll study that later. This change in magnetic field is then sensed by this wire. Here, magnetic field will now give rise to an electric current. Another EMF will be set up out on this one. So you put one, it's absolutely magical. How do you think that this MagSafe chargers are working? You don't give any contact. So there is a coil inside here, and there's a coil on the charger. The charger coil creates a magnetic field. That magnetic field is sensed by this mobile, and it starts developing. I have to give a current to it. Do you understand? And you can actually do it. So when an electric, in fact, when we work with electricity and you're working in marriage pandals and all, there'll be a lot of cables which will be lying. And if electricity, if AC current is going through it and there is another coil which is nearby it, that is no way connected, and Neha goes and touches that, shock kha jaoge. This is called electromagnetic induction. A pulsating signal on the primary will create a pulsating signal on the secondary. Understood? This thing in our diagrams is represented in this manner. In this chapter, all you need to know is this is known as a transformer. Typically, what we will do, you will see that this coil is shown smaller. And when we do transformer calculations, we will see NP over NS is equal to VP over VS. Now, we have, these are not in your syllabus, just to make you understand. We have 240 as our source. We need 6 volts. So you get the ratio. Based on that, you can make the turns on this. This transformer is going to help me reduce 240 volts to 6 volts. This is also AC. This is also AC. It does not change the current from AC to DC. It will just step down the voltage. All our devices have got a transformer, and that is what heats up. That's why these adapters become warm. Next class, tell me, I'll come show you a transformer. So transformers will have a primary side and they will have a secondary side. You give high voltage, you get less voltage. This is called a step down transformer. You see at this main gate when you enter Pebble City, I'm entering Pebble City. This is the security booth. On the left side, there's a gravel enclosed area where there's a transformer kept. There will be gray color transformer kept. You can see next time. That is where you have the clothes collection box Gunj. Between that and as soon as you enter Pebble City, on your left. Yeah, the main gate. Right at the main gate. So there the voltage is coming, 13 kV is coming. 13,000 volts. At home you are using how much? 240 volts. 13 kV will be dropped down to 440, and at the basement of the tower 440 gets converted to 240 because you need less voltage. Right? So this is, and you can do the reverse way also. The reverse is called a step up. Lower voltage can be stepped up to higher voltage. If time permits, I will tell you one nice application of this, which you use every day, but you must have not thought about it. You can do this also. Have you understood? So this is called step up. This will be a step down. Our job is to see the step down. We call it a rectifier. So your books will be straight away drawing the transformer. Now you should know why the transformer is used. So let's go ahead and try to understand. Yeah.
The lack of charges we have.
That whole thing is in physics we will call it a rectifier. It is bringing down 240 volts from the terminal to 18 volts DC. But they are very high quality rectifiers. Why high quality? Let's see that. Okay, so our job will be, we will have what is known as, this is the laminated core in terms of our diagram representation, and this is my transformer. Okay, let's see two different types. This is my transformer. So this is my transformer. What is my transformer going to do? My transformer is going to take a signal of say 240 volts AC, and it will convert it into what? 6 volt AC. This is also pulsating. Many people think AC means the current in which you die. Low voltage can also be AC. Okay, let's see AC and DC in terms of representation. Say this is time and this is say voltage, or say let's say this is a current signal. An AC signal will be shown in this manner. What does it show? Sometimes the current is positive, sometimes the current is negative. It's pulsating. 50 hertz, that's why we say. In 1 second, 2 times it is pulsating. So 50 times. So let's see a DC signal. A DC, so this is called a AC signal. Have you understood? Positive current will be there. A DC current can be, a DC is unidirectional. Is this DC? Yes. This is negative current throughout. This is also DC. Direct current. आर पार नहीं कर सकता टाइम एक्सिस को. It cannot go positive and negative. Okay. Children, tell me, is this DC? Yes, this is also DC. This is a variable negative direct current. Is this DC? Yes, this is DC. This may be positive 5 volt. Is this DC? Yes, this is also DC. Is this DC? No. Now you've got the idea of what is DC. DC should be unidirectional. Variable हो सकता है, constant हो सकता है. All the modems and everything, they are using 9 volt stationary. You want peak, it should be 9 volt. Neither up, neither down. It's just like you're buying milk, you want A grade pure milk. Do you think you get very pure milk? No. You can get close to pure. That is what is the magic we're going to see out here. So our first job is to reduce the voltage. The transformer will do what? The transformer will step down alternating EMF, you say, or you can say an alternating current, whatever it is. Current is whenever you connect a load across a EMF source. So this is what the transformer is going to do. Right. So I'll just erase this portion because here is where you'll see all the magic happening. So let me erase this part. Okay. So, and let me draw some waveforms. Right. This is a time. So my input signal is coming in this manner. Okay, bacha? Have you understood? This is my input. Input to the transformer. This is the input to the transformer. Let me make it better. 1 minute. 1 minute. Okay. So let's take our this is the AC input. This is called a half cycle, right? Half cycle. So this is one cycle. This is another half cycle. I'm drawing this axis to show what is the type of output I will be creating, okay? By using our diodes. Just try. This is the input signal. Children, this is the input. And finally, this is my output, rectified output. Let's see. Let's see the magic. So AC signal is going inside, right? And you're getting an AC signal out here. Obviously, I'm giving some cases where we can get a 6 volt AC, right? Okay. Now, what we do is that we bring one diode out here. Okay, we have brought a diode, and this is typically my terminal, and I have connected my load out here. Load means whatever. This is my load resistance. Load ka matlab samjho. It can be your bulb or it can be a LED that you have connected, which it is an apparatus which runs at how much? 6 volt DC, and you have tried to connect it here. Obviously, any apparatus has 2 fangs, 1 fang here, 1 fang here. Now let us see the beauty part of it. This is my diode D1. Okay. Now all eyes on the board, then only you'll understand. Now you're getting what supply are you giving? You're getting an alternating supply, a low voltage supply. During the first positive cycle of this alternating, so the EMF, this diode is forward biased. Are you understanding? There will be, see, this is changing, this is 50 hertz, means 50 cycles per second. Are you understanding? In 1 second, it is changing 50 times. You can't even, actually, if you glue a bulb out here, the bulb is actually, it lights, it's changing its polarity every time, but the speed is so high that you can't actually make it out from your eyes. If you would have connected an LED to a AC source, we drive LEDs on DC. Say suppose you take an LED and you give it a 3 volt AC, the LED will flicker. Kabhi positive, kabhi negative, kabhi positive, but it is happening at such a fast rate that your eyes are unable to see it. So there is some positive cycle at which this diode is becoming what? Forward biased. Once a diode is forward biased, don't you think the diode should conduct? Yes. So if the diode conducts, this is the positive cycle, the diode has given you an output. Fellow has got a voltage. In the immediate next cycle, this diode is reverse biased. It just becomes quiet. Again, in the positive cycle, he becomes forward biased. No, there won't be anything. As I told you, negligible, that minority current is of no use to us. This is called half wave rectification. You are getting DC output. Do you agree? Are you getting any output which is negative? No. But what about this part? Blank. ये अपने को काम में नहीं आएगा. If you connect our modems and all to this, then the modem will be tuck, 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 because suddenly for every half wave there is no signal. This is called a half wave rectifier. So this is there in your syllabus. So what is a half wave rectifier? In a half wave rectifier, we'll have a transformer. Transformer's job is to step down the voltage. Simple. AC को AC में ही change किया, लेकिन adult को बच्चा बना दिया. That bacha AC is fed through one diode. Now AC comes in this manner. Every positive, the diode lights up. Yes, please go. Every negative, he says, I don't know you. So you are getting half wave rectification. Rectification means ये सब नहीं हो सकता, इसको सीधा करो. Rectification, best example. Rectify him. Rectify him मतलब लाइफ को सीधा ले जाने का. ये कभी डामाडोल नहीं चाहिए. अब इसका हाफ वेव रेक्टिफिकेशन हुआ है. A rectifier is reduced voltage but converted to DC. Is this much clear or not? If there is any cloud, tell me. I mean, these are my favorite things. I don't need any book. This is not used, but you should understand. If you don't burn a puri, Neha, how will you understand how to make the puri? She has seen cake baking from her childhood. 3 cakes have to go waste. Then only you will develop. This is half wave rectification. But this is not doing our job. In fact, if I connect this to any speaker, you know how the speaker will sound? The song will come, but the speaker will, we call it humming. It will keep on humming. तो नहीं चलेगा, अपना काम नहीं हो रहा है इसमें से. अपने को steady DC चाहिए. ये steady नहीं है. It's coming in that manner. Ready for full wave rectification then? Have you understood what is half wave rectification? Resistor is nothing but your load. It can be your speaker, modem, anything. Every job in electronics, every object that you want to operate is called a load. This is known as load. Have you understood? I want to test my plug point. So what will you say in crude language? Sir, connect a bulb. As an electrical engineer, I'll say put some load on it. Engineering is all about load. You have designed a cradle. You'll say place the baby. Put a load. We don't say baby, load. So put a load. This is a load. Ultimately, it has to drive a load, right? That load can be a modem. That load can be a battery charger, whatever it is. Arjun, clear? So we have got half wave rectification. ये तो अपना काम नहीं कर रहा है. Now we need something which is known as full wave rectifier. Full wave rectifier में there will be a small change in the way the transformer will be. This is the transformer. The transformer that I showed you, we do get it in the market. But this transformer we will not use for rectification. This transformer we will use for what purpose? Where we want low voltage AC. Yeah, full DC नहीं करेगा, full wave rectification नहीं करेगा. So full wave rectification के लिए the transformer is slightly different. And I'll tell you what the transformer looks like. Instead of having 2 fangs, it will have 3 fangs. This is called a center tapped transformer. The transformer will have 2 input, 3 outputs. Right? Let's see how it happens. We will give input 240 volts AC as usual. Now the output you will get is, you will get an AC output here. This actually has 2 coils out here. 1 coil, 1. You will get a AC output out here. This is also 6 volt. This is also 6 volt. And this will be maintaining 0 volt. Such a transformer is known as center tapped transformer. Center tapped transformer. Center tapped transformer. By the time you all draw, let me also make my characteristic curves. On these things I have spent so much of my childhood, while making these adapters and transformers. See, this has become very easy for me in grade 6 and 7. My project was used to be this. If I score good in tests, get me a transformer, and I'll tell you what all struggle we used to have. Okay, so this is the input signal. Okay, chalo. Now our connection will be slightly different. अब एक डायोड की जगह हम 2 डायोड लाएंगे. We'll connect 1 diode here and we'll connect 1 more diode out here. Got it? And we will combine these 2. So this is 1 terminal for our load, and obviously the center comes the way it is. This is untouched. This is, and now my load will be connected here. Whatever bulb or whatever, this is my RL or the load. In book they will show you here, this is the same drawing. Now the 2 diodes have to be named as diode D1 and diode D2. Okay? Now you have to be very careful now. Diode D1, D2. Right. Okay. Now take one signal, take one pulse, take this pulse. When diode D1 is sensing a positive bias, don't you think diode D2 at that time will be sensing a reverse bias? Yeah, at the same time, see, this is a pulsating signal. This is 0. If this fellow becomes positive, this fellow becomes negative at that time. That positive negative is pulsating. How much? 50 hertz. In 1 second, 50 times. It's changing. So, at a particular instance, I'm saying, at some instance of time t, say this is positive, then this fellow should be negative. You agree? If this is positive, don't you think diode D1 is forward biased for the positive cycle? So D1 should give me an output. D1 should be giving me an output. D1 gives me an output, right? Now, second cycle. In the second cycle, we have reversed now. Now this becomes negative, this becomes positive. D2 has become forward biased, D1 is reverse bias. D1 चुप हो गया, लेकिन D2 बोलेगा मैं आएगा ना माँ तेरे हेल्प के लिए, मैं देखो. How such magic happens. Are you getting it? And in the next cycle, this is say D1 is forward biased. At this section, D2 is reverse biased, no current. Now what has happened? D2 is forward biased, D1 is reverse biased. Again D1. एक काम तो हो गया. Was the voltage lowered? Yes. Has the voltage? See, what is the difference between voltage and current, children? Again, get one fact corrected. This is a cell. A cell has a voltage. When you connect a load across a cell, again Zoe, load means a bulb, then a current starts to flow in it. Current flows when there is a load across whom? A potential source. Current is the child. Create one big building and one small building and put a plank. Potential has been created. Who is the load? The child. But how? So current starts flowing from higher potential to lower potential. So diode D2 starts conducting. Now let's see what is the magic happening. So let's start explaining once again. A full wave rectifier consists of a center trap transformer. The center trap transformer has got one ground, one zero, and one positive terminal at a time, one negative voltage terminal at a time, right? At a particular instance, this is going to lower the voltage. But how does it lower? So when you go to a market, how do you buy this transformer? We will buy this transformer as 606 transformer. So when I go to the shop, I'll say, "Ek 606 dijiye." He will say, "How much ampere do you want?" Because this transformer is going to give an output which is suitable for a certain current requirement. If you want more current, like say speaker systems and all, have you seen all UPS is very heavy? All speakers are very heavy because they have transformers which have more amperes and the cost goes up. A 606 transformer, if you buy with a 50 milliampere, this in market they will give you at 25 rupees in Delhi and all, here also. But if the same thing I want in 1 ampere, the price will go to 350 rupees because more amount of copper has been used. 606. Similarly, for 3 volt application, what is my transformer? 303. 9 volt, 909. What was the previous transformer? 012. 06. Because it has only one output. This transformer will be sold in the market as 06 or a 03. ये सेंटर टैप नहीं है, इसमें सिर्फ 2 पार्ट्स आते हैं, बट ये क्या है? दिस इज सेंटर टैप 606. ठीक है? So we take a center trap transformer. After the center trap transformer, each of the output, positive and negative, we connect 2 diodes in this fashion. During the first half cycle, diode D1 is forward bias, gives an output for the first half cycle. This is the first half cycle. This is the second half cycle. Diode D1 is forward bias, gives an output. During the second half cycle, D2 is forward biased, D1 is reverse biased. So D2 gives. But here also there is a challenge. अपने को DC मिला, smooth नहीं मिला. It has a wave front. If this, I used to do these, okay, and then if you connect this now, see it. What we used to do, we used to have some small sort of an amplifier, and then an adapter is to come. Then I'll make my own adapter. And when I connect my own adapter and I start playing that, have you seen in desktops we used to have these small speaker system which used to come with an adapter? They give you very crystal clear sound. But in our days, when I connect an adapter which is made in this manner and I connect it, like a continuously it will hum. It's humming because it is not getting smooth 6 volt. ये 6 volt बढ़ रहा है, घट रहा है, घट रहा है, घट रहा है, variable. Now we need something more which has to come in rescue. We bring a device which is known as a capacitor. Now what is a capacitor? In chapter 1 we will study. Capacitor is simply a device which has got 2 plates and we just connect it across any sort of a cell. Just connect it across a cell. So this is positive, this becomes all positive, and this is negative, so this becomes all negative. It's an energy storage device. Take a capacitor, 2 fangs, and just put that into your plug point. Connect it, nothing will happen. It has got energized. Now just take the 2 fangs and touch her body. Tapach! It will just discharge. Have you seen the camera flashes? How do they glow so bright? Whereas we are using only 2 cells inside them. The torchlight doesn't glow that bright. The camera flash does not operate on the battery. The battery is used to charge up the capacitor. So if you see in your house, if you have a roll camera, any roll or any camera which uses external flash, you will see photographers, when they switch on the flash, it will make a sound. It will make a sound. Means the flash is charging up. And then the green light will come up. The photographer will not click the picture until the green indicator comes. Green indicator means now the capacitor is fully charged. Once he presses the shutter, he is not using the battery. It is releasing all the energy in one go. Microwave. Microwaves have got built-in capacitors because they are needed to generate that high voltage. And if your microwave goes bad and you have put up a complaint today, the technician usually in our city, he will come 2 दिन बाद. The first thing he will do after opening the microwave is he'll take his screwdriver and short these two. That capacitor stores the charge almost till 4-5 days also. It will be fatal for him. The first thing when you open a microwave, the first thing is to short the capacitor. Fans have got capacitors. Touch करके sound करेगा. They store charges. So here what we do, we bring a capacitor for our rescue. Now between these two lines, this is the output. This is the output. This output is coming like a bunny jump. You want it to be smooth. So we will introduce one capacitor out here. And more the capacitance, the charging is faster. So what the capacitor does is, every cycle at here, the capacitor will actually, this is rising, the voltage is rising, the capacitor starts charging. Then the voltage falls. Whenever there is a portion where the voltage will be falling out here, right? From here the voltage falls. At that time the capacitor says, "मैं charge कहाँ गया? मैं charge कहाँ गया?" And once it has no charge, have you connected it across a Zoe? Yes, you have connected it across a Zoe. Capacitor will immediately discharge. By that time, the second peak will come. Again, capacitor says, charge. I've started getting charged. The capacitor gets charged. Again, the moment it sees a discharge, it will start giving in this manner. Did you still get a flat? No, not so flat, but much better than what it was before. Slowly, you will see, if you increase this capacitance, if this capacitance is increased, the filtration improves. Since you are studying the last chapter first, we have got another device which is known as inductor. So a capacitor, when you put here, we say that this capacitor works like a filter, and we call it a C filter, capacitor filter. Later on, we get something which is an inductor. An inductor is like a solenoid. This is called a L filter. Inductor will be connected in series with the load. If you connect an inductor, this is even better. What do we call it? L filter. तो दोनों को connect कर दो. That is even better, called a LC filter. So if you find in any market that the adapters are getting costly, if you see a good charger, very costly, sometimes you get 200 rupees charger, you'll get 2000 rupees charger. दोनों ही तो mobile को charge कर रहा है. You are seeing the mobile glowing up, your mobile is actually fighting with the quality of input it is getting. Why does these Apple and other devices cost so much? Because the type of filtration that they are giving is top notch. Even in desktops, we have got a device inside desktop which we call as SMPS, switch mode power supply. The 220 volt which goes and feeds the desktop, this switch SMPS will give me 3.1 volt DC, 5.1 volt DC, 12 volt DC, and negative 12 volt DC. Super clean filter. Therefore, if you want to do very good experiments at your home, there are two choices. In market, suppose I'm a hobby electronist, okay? I'm a hobbyist. I need these power voltages, 3 volt, 5 volt and all. What can I do? Go to the market, and we also get transformers which are variable. 6, 4.5, 3, 9, 0. And then create different outputs with a toggle switch, tuck, 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 tuck. That will also, what you do, that will also do our job. But the type of output that you will get is not clean. Like, you know who is a rack picker? A guy who goes and picks from scrap. So whenever in Pebble City there is any electronic disposal, my mom says, "Ja, rack picker." I become rack picker, because you might be disposing your old PC. Oh, guy, this is of no use. It's my trash. I bring that PC, open it up, and I take out the SMPS. This is my bench power supply for my home device, all my experiments, because this is going to give me clean 3.1. Filtration is superb. Superb is the filtration. Sony, why do their head? Bose, why do their things cost so much? They are investing on this. At the end of the day, you need top-notch quality. That's why nowadays in chargers, we are reducing the size of the transformer. We are working on many other filters. There's a girl who studies, BSc physics, and she puts up these small reels. How to fall in love with BSc? Why only engineering? So there, the transformer size is reduced. If you open up your mobile charger, you won't find a big transformer, very small. Filtration quality is excellent. So what is a half wave rectifier? A half wave rectifier rectifies only a half wave of a pulsating alternating signal, whereas a full wave rectifier will rectify complete full wave. Initially, we will get, these are known as, the word we use for this is known as ripples. To take care of the ripples, what did you do? You introduced a capacitor as a filter. What does the capacitor do? The capacitor charges as the voltage goes up, and when the voltage goes down, capacitor says, where is my life support? So whatever energy it has, it will just puke all the energy on that load. So load keeps on. See, the load is very happy. When the voltage went up, the load is getting a voltage. When the voltage goes down, the capacitor is feeding the load. Hence, a little bit of an topsy-turvy, but this is how. In fact, you can do experiments in higher classes in engineering. We learn how the value of capacitance can be improved to improve this ripple factor. This is all about your syllabus.